Hello, this is Mr. B, and I wanted to bring you a short video discussing the distributive property and how to work with that to give you some extra help in this. So we're looking at a pattern here. If you ever see this pattern where we have a number times two other numbers that are in parentheses, either being added together or you can see over here being subtracted, then we can use the distributive property to rewrite this in a different way. Notice that the number is written right next to parentheses, so that is a multiplication symbol. So when you see a number written right next to the parentheses, that indicates multiplication. So you don't have to have a multiplication symbol in between there. So that's one way to recognize that. And another thing I want to go over real quickly is how do you say this? Like, how do you say this first problem right here? It's not 10 times 4 plus 5, because that would just mean we're multiplying 10 times 4 and then we add 5 to it. So that's not exactly what we're doing right here. So what we would say is 10 times the sum of 4 and 5. So in this pattern, I'm going to go up here with these variables. We would say x times the sum of y and z. Or sometimes we could say x times the quantity of y and z, or y plus z. And over here, if it's a subtraction problem, we would say x times the difference of y and z. So using the word sum and difference indicates that there's parentheses involved, combining those two add-ins or combining these two numbers that are being subtracted. So in this first problem here, we have 10 times the sum of 4 plus 5, and if we use the distributive property, we are simply going to, let me get my pen here, multiply the 10 times each of the add-ins individually. Now keep in mind, we're not finding the answer. The goal here is not to find the answer. Okay, that's pretty simple. That's not even 6th grade math right there. The goal is to rewrite this in a different way. That's what properties do. Properties, any of the properties, helps us to rewrite an expression into an equivalent expression. Just write it in a different way. So that's our goal here. So how can we use this property, distributive property, to rewrite this? Well, we would distribute the 10 to each of these add-ins individually. So instead of multiplying 10 times the sum of 4 and 5, we could do 10 times 4. And so we would write that out, 10 times 4. We could use a dot, or the x would be fine. In this case, 10 times 4. And we would also do 10 times 5. Notice I'm drawing these lines. Sometimes that will help us just kind of keep track of what we're multiplying. It reminds us what we're doing. And then since we're adding inside those parentheses here, we're multiplying by a sum, we want to find a sum. So here is our full expression rewritten in a different way. A lot of times we will put parentheses around here just to emphasize these two terms that we have right here, but you don't need parentheses. It doesn't change the order of operations. We still would have to do 10 times 4, which is 40, and then we would do 10 times 5, which is 50. So we do see that this is now an addition problem with 40 plus 50. So we started off with a multiplication problem, and then we ended with an addition problem over here, and they're all equivalent to each other using the distributive property. So if we used it with a subtraction problem, we would simply say 8 times 3. So we're multiplying 8 times 3. You can use the x, or you can use parentheses to show multiplication. 8 times 3, and also 8 times 2. So the 8 is being multiplied by these individually. And then in this case, since it's a difference, we have to make sure we put the correct symbol in place here. We can use it with variables. No problem there. 6 times x. Oh, great, my cat is here now. And then 6 times 5. We could put that in there. And we are adding those together. So you can actually go one more step here also and do 6 times x plus 30. So, but all of those are equivalent or equal expressions right here. So let's go the opposite direction. So now we can also, if we start with an addition problem, we can work backwards and bring it into this pattern where we have a factor out here multiplied by a sum or difference if it's a subtraction problem. And a lot of times our book, I know our textbook, asks for the GCF, the greatest common factor of the two. But you can rewrite it with any factor. But if we look at 18 and 22, we want to come off to the side over here. And so on your paper, you would want to go off to the side to find the greatest common factor. So we use the method dividing by primes method to find the greatest common factor, but you can use other methods as well. So 18 and 22 have a common factor of 2. So we can divide by 2. So we're just using division right here. 18 divided by 2, 22 divided by 2. And we end up with 9 and 11. Well, 9 and 11 don't have any more common factors. So we're done here with our division process. Our GCF is our factor. It's the only factor that's common. So this would go into our first place right here. This is the place where our factor goes. And we are multiplying by a sum of the other two factors. So the other two factors is what we see right here. These two factors are the others, because 2 times 9 equals 18, and 2 times 11 is the 22. So here we can just put those in place. We're adding these two because we're adding here. And that's our final product right there. So we went from an addition problem, and now it is a multiplication problem. 2 times the sum of 9 and 11. And we can check our work very easily. We can say, well, let's just check, make sure we have this. 2 times 9, that's 18. 2 times 11, that's 22. Good. We should be good to go. So let's try this with 30 and 42. Let me use green down here. So we would want to do, all right, 30 and 42. Let's make sure we find the greatest common factor. You might look at this and say, well, I think I know a common factor. 2 is a common factor. So let's divide both of them by 2. These are both even numbers. All even numbers are divisible by 2. So we could stop here and say, well, 2 times the sum of 15 and 21. And that would be correct. That is an equivalent expression using the distributive property. But we want to go one more step because we want the greatest common factor. So we can also divide by 3. We have 5 and 7. So 3 is a common factor also, but our greatest common factor is when we multiply these two together. So using the greatest common factor, oftentimes a test or the textbook will ask you specifically for the greatest common factor. So 6 times, here's our other two factors right here, 5 and 7. So we say 5 plus 7. Okay. So that is using the greatest common factor to start off with an addition problem and rewrite it as a multiplication problem using the distributive property. So those two, you'll see those two types of problems in your homework, in tests, and so that's how you do it. Thank you. Bye-bye.